Hi, if you ever used coding agents like Codex, Claude Code, or Cursor, you might be excited about how good they are at doing what you want. And yeah, sometimes the code is not very good, but very often, especially recently, in the last few months, the quality of agents improved a lot, and they can really handle complex problems, generate great plans, and implement complex feature autonomously. In this video, I wanted to show you some latest research which shows that despite the fact that they are very good at implementing something, they can actually over time make damage to your code base, to your architecture of your project, to your tests maybe. I want to show you this paper because it shows how agents over time add regression to your code base. So if you are interested, please continue watching. So first, let me quickly explain how usually coding agents are tested. So popular benchmarks like SWE-bench or SWE-bench verified is the most popular benchmarks for testing coding agents and LLMs in general for coding. And what they do is they take a lot of GitHub repositories with some issues and with snapshots of repositories before issues. And then, so they have a snapshot of repository, they have a specific issue, specific bug, and then they ask agent to fix this bug, fix this issue. So there is a new snapshot of a repository with a fix, and they see how many tests pass after this fix, after applying an LLM. This is a fair approach, which can really show how agents compare to each other. It is what it is. This is what we have. The problem with this approach is that these benchmarks, they don't show how code base is affected over time. So what happens with a repository, with tests, with quality, if we run agents over and over and over again and move completely to agentic development? So what happens? In this new paper that I mentioned, authors decided to tackle this problem and evaluate how agents perform in the long run. So they've compiled many tasks, created two agents, architecture agent and developer agent, and made them alternate. So architect agent is planning something, and then developer agent is doing something. And then they measured via some external oracle how tests are performing over time, so whether they are degrading or whether they still pass as originally before this agentic loop. So they did up to 20 iterations and tested different models, and they found that most of the models have regression on 75% of tasks. So it means that for most of the models, if we take a model for 75% of cases, it actually introduced some bugs, some problems, some regression in the code base. The best model was Opus 4.6, and they have about 24% regression rate. So it means like 24% of tasks had some regressions, but in most of the cases, no regression. But even models like GPT 5.2, they had this rate above 75. So it means above 75% of tasks had some regressions. What is the root cause? So the root cause for this problem is that LLMs and agents specifically, they are local optimizers. So it means that when you ask an agent, hey, I want you to do this, plan this, and then implement this, very often it does a good job in implementing it, but it doesn't see the whole picture, the whole vision. So it tries to kind of maximize the output on given task. And eventually, there appears to be some technical debt in your code base or even bugs introduced. I think with the current level of skills, current level of coding that AI agent can provide, this should be our main focus for us, for human developers. We should be not just people who think about architecture. Again, architecture is something you can eventually delegate to the model. But this connection between architecture and between local development and improving it over time and making it scalable and all this stuff, so this is still on us. And if we don't pay enough attention to it and just blindly ask agent to implement feature after feature after feature, and then fix bugs, then we will have eventually some problems in our code base, especially if we're thinking about like large code bases and enterprise repositories. I hope that was useful. Thank you very much for watching. Please subscribe to our channel. We post every week tutorials about Cursor, Claude Code, Codex. See you next time.